This is Physics 1 course. In this video I will teach constant acceleration motion. A motion with constant acceleration means that if I have the acceleration vector, then the components are not function of time. So therefore I have ax, which is a constant, I hat, plus ay, which is again a constant, j hat, plus az, k hat, and that is also a constant. Now I know that a is equal to dv over dt. Now I can rewrite this equation as dv equal to a dt, and then integrate both sides. So therefore integration of dv equals an integration of a dt. So what this actually means is integration of dvx I hat plus integration of dvy j hat plus integration of dvz k hat equals to integration of ax dt I hat. So I hat is a constant, it's not a function of time, so I can take that out, plus, and the same for j hat and k hat, a y dt plus k hat a z dt. Same here, so I hat can be taken outside. Before taking the integral, we also need to fix the intervals. So let's say we start from time 0, because this is dt, so time 0 to time t. And let's say at time 0, vx was vx naught. And then finally it becomes vx. Same here, vy naught, vy, vz, vz naught. So here again 0 to t, 0 to t. So it's basically here. So I had v naught and v. Here dt is from 0 to t. So that's how it is translated here. Later we will see that I hat, j hat and k hat are independent. So for now you just remember that they are independent. So when I have an equation like this where there are I hat, j hat and k hat in both sides, you just need to put the components of each equal to each other. So meaning that components of I hat are equal, then components of j hat are equal, and the same for k hat. So I will solve one of the components, and since the rest are very similar, and then we can have we can know the answer for the rest. So let's say for I hat I have integral of vx naught to vx dvx I hat. So I don't write I hat anymore because I have one I hat the other side that they cancel. So integral of t from 0 to t ax dt. Now ax is a constant, so I take it out, ax 0 to t dt, and this is just axt. From 0 to t it's t minus 0, so it's t. Now this here is vx minus vx naught equals ax t. For y and z, you just need to replace x by y, y, or z, z, z. So this is a important equation for a constant acceleration motion. Remember, it is only valid if ax or ay, az are constant. So now let's say I have Vx equals dx over dt. So therefore I can make another integration to determine x, right? So dx over dt equals Vx naught. This is a constant. It's x component of the velocity of the object at time 0. That's why I have a naught. Plus ax t. Now I multiply all sides by a dt, then a dt here, then these two cancel out. I then can integral. So from x naught to x dx equals from 0 to t. So here basically means at time 0 I have x naught. The object, particle or person is at x naught, and at time t it is at x. Vx naught dt plus 0 to t ax t dt. Now taking the integral, I have x from x naught to x equals Vx naught is a constant, t from 0 to t, plus ax comes out of the integral because it is a constant, then integral of t is t square half from 0 to t. Now therefore x minus x naught equals Vx naught times t plus half ax t square. And the same thing for y. So basically I have y minus y naught equals v y naught t plus half ay t square. And the same thing for z. So remember we also had another equation earlier. It was Vx equals Vx naught plus ax t, and for y I said just replace the x by y. Vy naught plus ay and t, and for vz again the same thing. So now these set of equations can be used to solve almost any motion with constant acceleration. Let's now solve some examples using this set of equations. This is a simple example that I'm going to solve now using these equations. So a ball that is at rest falls from a bridge that is 10 meters above the surface of the earth. When does it hit the ground? What is the velocity at this time? So the very first thing that we need to solve a problem like that is a coordinate system. So we need a xy a reference frame. So let's say here is the surface of the earth and here is the bridge, and now I put my coordinate system here. So this is x and this is y. So now let's read the question, the example. A ball that is at rest. So this has a meaning. Let me change the color. So when it says rest, that means it's 0. velocity is 0. So, and we need to solve y components here, because the object will be moving only in the y direction. So object is at rest means v y naught is 0, although vx naught and vz naught are also 0, but this is the one that is important to us. From a bridge that is 10 meters above the surface, so that means this distance is 10 meters, or means that y naught is 10 meters. So basically y naught means the position of the object at time 0. So it is 10 meters above the ground, and my coordinate system is here. It's 10 meters this distance. So I have that as well. Now let's see how I can use it, these two, to solve for time, because it's asking when. It means what is the time when it arrives at the ground. So what is the y of the ground? So ground is located at y equals 0. So at time when it arrives at the ground, y is 0. So now let's put everything here. 0 minus y naught, which is 10 meters, equals vy naught is 0, so this term is 0, plus half ay t square. Now from this equation I can find t. So let's say t is equal to minus 20 meters, 2 times 10 meters, divided by ay. And since it's a square, I take a square root. So now I also need to find ay, and then I have the time. So whenever I'm solving a problem close to the surface of the earth and air resistance is negligible, then the acceleration of the object, no matter what size it is or what it is made of, is shown by this vector. So this is the acceleration due to gravity. It is always downward toward the surface of the earth. Its magnitude is 9.8, and since it is quite important, it is given a special symbol g, equal 9.8 meters per second square. This is basically the magnitude of this acceleration. So you also need to memorize this, both the direction and the magnitude. So now here ay therefore is minus g, or minus 9.8 meters per second square. So if I put that inside, then I have minus 20 meters divided by minus 9.8 meters per, so second square comes up. So now meters cancel out. So I have square root of 20 over 9.8 seconds. Now let's see what is the velocity at this time, which is this time. So now we need to use this other equation, and we want the velocity vy equals vy naught is 0 plus AY was already here, minus 9.8 gravity meters per second square times t, which is square root of 20 over 9.8. So therefore y, the velocity is, and there is a second here, so this second and one of these seconds cancel out, therefore velocity Vy equals negative, and the negative is because the object is going downward, so it is consistent. 9.8 times square root of 29.8 meters here, and seconds and second square cancel, so we get 1 second. Thanks for watching. Please subscribe to support my channel. If you have any question or comment, please send me an email at open.physics.project@gmail.com. Thank you.